Hi everyone, welcome to the next video of the GCSE Higher Revision Countdown, and it's 98 days to go into a new GCSE paper, and today's topic is Pythagoras, or Pythagoras' theorem, or as I like to call it, Pyfabulous, because it's one of my favourite topics. So if you have the revision cards, card 64 is the Pythagoras revision card, and I remember on the back you've got the video, the exam questions and the answers and so on, so that's quite useful, that card 64 and Pythagoras' theorem. But in this video, remember, I'm going to go through now Pythagoras' theorem. I'll try some examples, or I'll go through some examples on how to use Pythagoras' theorem, and then you'll have some to try yourself, and then at the end of the video I'll talk about the practice questions and where they are. Okay, so today's topic is Pythagoras. So Pythagoras' theorem is a squared plus b squared equals c squared, where a and b are the lengths of the two shorter sides of the right angle triangle, and c is the length of the hypotenuse, the longest side of the right angle triangle. So here we've got a right angle triangle, and we're going to use Pythagoras' theorem to find the length of this diagonal. Again, if you want to try this yourself now, feel free to press pause and to try the question yourself. Okay, so here we've got a right angle triangle, and we're going to label the sides A, B, and C. So A and B are the two shorter sides, so I like to call it A and B, where A is the smallest one and B is the middle one, if you can. You can't always do that, but it doesn't actually matter which way around you label them. So if you had to call it A and B, that doesn't really matter. But we have to call the hypotenuse this longest side C. So we've got A squared plus B squared equals c squared. So that's Pythagoras' theorem. And now we're going to substitute in the values that we know. So a is equal to 6, so we've got 6 squared, plus b, which is equal to 8 squared, is equal to c, which is equal to x squared, because c is x, so it's x squared. Now we just need to work this out. We're going to do 6 squared. Well, 6 times 6 is 36, so 36 plus, and then 8 squared. 8 times 8 is 64, so 64 is equal to x squared, the length of that side squared. Now 36 plus 64, that's equal to 100, so that's 100 is equal to x squared. So that means the length of this side squared is 100. This side obviously isn't 100 centimeters, that's far too big. So that's the length of the side squared. So what we're going to do is to find the length of this side, we're going to square root. So we're going to do the square root of 100, and whenever, so x is equal to square root of 100, and the square root of 100 is equal to 10. So that means that x is equal to 10 centimeters, and that's it. So in this question, we label the sides of the right angle triangle, A, B, and C, where A and B are the two shorter sides, and C is the longest side, the hypotenuse. We then wrote down Pythagoras' theorem, and we substituted in our values. We then worked out what those were, so we squared and so on, we added, and then what we done was we got the x squared was equal to 100, so we done the square root of 100, and we got the x is equal to 10. Okay, let's have a look at another question. So this time we've got a right angle triangle, and we've got the lengths of the sides being 18 centimeters, x, and 20 centimeters. And again, feel free to pause the video and to try this question out yourself. Okay, so to begin with, I'm going to label the sides of the triangle. So A and B are the two shorter sides. Now, I know that C is the longest. Actually, I'm going to call C, the one opposite the right angle, the hypotenuse. That's equal to C, so let's call that C. And then A and B, I'm not actually sure which one's the smallest in the middle, so I'm just going to call it A and B. It doesn't actually matter which way around you label those. So let's write Pythagoras' theorem down. That's A squared plus B squared equals C squared. So we've got A squared, that's x squared, so x squared, plus, and then we've got b squared, that's going to be 18 squared, is equal to c squared, and that's going to be 20 squared. Now this is a calculator question, I'm telling you that now. So we've got x squared, and then we're going to do 18 times 18, or 18 squared on my calculator, that's plus 324 is equal to, and 20 squared is equal to 400. So we've got the x squared plus 324 is equal to 400. Now we want to find out what x is, so we don't want this plus 324 here, so I'm going to subtract that from both sides of the equation. So subtract 324 and subtract 324. On the left hand side of the equation, we're going to get x squared, that's fantastic, and on the right hand side we've got 400 take away 324, and that's equal to 76. So the length of this side squared is 76. Now this actually isn't going to be 76 centimeters, so that doesn't make sense here because this is the longest side. So we need to find out what x is, so we want to get rid of the squared, so we're going to square root. So that means that x is equal to the square root of 76, and the square root of 76, whenever we work out the square root of 76 on our calculator, we get that's equal to 8.71779 and so on centimeters. And let's round that. I'm going to round that to 2 decimal places, so that's going to be 8.7, then we've got 17, so 2 centimeters to 2 decimal places, to 2 decimal places, and that's it. Okay, so we've looked at using Pythagoras' theorem to work out the length of the longest side of a right angle triangle and the length of a shorter side of a right angle triangle. Pythagoras' theorem actually can be useful to show whether a triangle is right angled or not. So if a triangle is right angled, then Pythagoras' theorem will work. Actually, I might be giving away too much of a clue for this question. So here's a question now. Feel free to press pause and to try the question if you wanted to, and then whenever you're ready, press play. Okay, so the question says Alison draws a triangle with side lengths 8 centimeters, 15 centimeters, and 17 centimeters. Is the triangle right angled? So I'm going to draw a little sketch. So I've just drawn a little sketch there of a right angle triangle, and I'm going to label the sides as a right angle. 8 is going to be the smallest side, 15 is then the middlest side, and 17 centimeters is the longest side of that right angle triangle. So there's a right angle triangle, and let's label the sides A, B, and C. And if this triangle is right angled, so actually I've put a right angle, it might not actually be a right angle. If Pythagoras' theorem doesn't work here, then this is not a right angle. If Pythagoras' theorem works, if a squared plus b squared is equal to c squared, that is a right angle. So let's have a look and see if I need to rub that out or not. So Pythagoras' theorem is a squared plus b squared equals c squared. So a is 8 squared plus b is equal to 15 squared, and that's equal to c squared, which is 17, which is equal to 17 squared. And then 8 squared, well, 8 times 8 is equal to 64, and then plus, and 15 squared is equal to 225, and then 17 squared on my calculator is 289. Now this is the key bit. If this adds together to be 289, then you get 289 equals 289. That means that Pythagoras' theorem is satisfied, it works, so that means that it would be a right angle triangle. If you add these two numbers together and it's not equal to 289, then this is not a right angle, and then Alison hasn't drawn a right angle triangle. So 64 plus 225 is in fact 289. So we get 289 equals 289, and that means that Pythagoras' theorem works, so that means it is the triangle right angle. The answer is yes, it is right angled, and that's it. Okay, so Pythagoras' theorem is useful to find the lengths of shorter sides of right angle triangles, longer sides of right angle triangles, or the hypotenuse of right angle triangles. Also to show if triangles are right angled or not. But sometimes you might find that Pythagoras' theorem is included in other questions, or diagrams that don't obviously look like right angle triangles. So here's a question here. The question says find the perimeter of the trapezium. So we've got a trapezium, and we're going to be using Pythagoras in this question. So things to look out for whenever you've got Pythagoras' theorem, it could be that you're given an isosceles triangle and you need to chop it down vertically and you'll end up with a right angle triangle and a right angle triangle. It could be that you've got maybe a rectangle and you need to cut it across diagonally and you get a right angle triangle there. Here we've got a trapezium, and we've been asked to find the perimeter of the trapezium. Well, perimeter, adding up the distances around the outside. So we've got 26 centimeters, 15 centimeters, 20 centimeters, and we need to find the length of this diagonal here. And if we can find the length of this diagonal, we can then add together the lengths of the four sides, and then that's the perimeter of the trapezium. So let's find the length of this side. Well, how do we do that? Well, if you have a look here, we can actually draw a line going across horizontally like so. And then that would be a right angle triangle here at the top. And in terms of the length of the base of it will be 15 centimeters. That's 15 centimeters there. And then in terms of this distance here, well, if this line is 20 centimeters and this line is 26 centimeters, the extra bit going from here to the top would be 6 centimeters. So we've got a right angle triangle where you've got the two shorter sides being 6 centimeters and 15 centimeters. And then we can use Pythagoras' theorem to find the length of this diagonal. So let's do that. So let's write down Pythagoras' theorem, and let's also label our sides. So A and B are the two shorter sides. Let's call that A and that B, and then the longest side, the hypotenuse, is C. So a squared would be 6 squared plus b squared would be 15 squared, and that's equal to c squared, which we're trying to find out, c squared. So 6 squared, 6 times 6 is 36, plus 15 squared, well 15 times 15 is 225, is equal to c squared, and that's going to be just c squared. Let's do our 36 plus our 225, and that's equal to 261. So we've got 261 equals c squared. I'm just going to turn this around, so I've got c squared equals 261. Now this diagonal isn't 261, that's that value squared, that length squared. So we now need to square root. So c is equal to the square root of 261, which is equal to the square root of 261 is equal to 3 root 29, or 16.15549, and so on. So the length of this side is 16.15549, and so on centimeters. Now we want to find the perimeter of this trapezium, so we now need to add up the lengths of the sides. So we've got the lengths of the sides, I'm just going to circle them in blue. So we've got 26 centimeters, the length of that side. We've got 15 centimeters, the length of that side. We've got 20 centimeters, the length of that side. And we've got the length of the diagonal. So let's add them together to find the perimeter of that shape. So we've got 26 plus 15 plus 20 plus 16.1554, and so on. And let's see what we get. So plus 26 plus 15 plus 20 is equal to 77.15549, and so on centimeters. And let's round that to two decimal places. So that'll be 77.1, and then it's 55, so let's round up to 0.16 centimeters to two decimal places, to 2 decimal places. So look out for Pythagoras' theorem questions whenever you're dealing with maybe
isosceles triangles or rectangles or even trapezia, or even finding distance between points on grids and so on. And if you want more practice on Pythagoras' theorem, in the description below there's a link to the practice questions on Pythagoras' theorem, and they'll be really useful for you to practice.
And that's it. So I hope you found that video on Pythagoras' theorem quite useful. Remember that a squared plus b squared equals c squared, that it can be used to show if a triangle is right angled. So if a squared plus b squared equals c squared, then it is a right angled triangle. But if a squared plus b squared does not equal c squared, then it's not a right angled triangle. Remember, it can be used in different situations as well. Perhaps if you've got an isosceles triangle, you can cut it down vertically and then you'd have a right angled triangle, and you might use Pythagoras' theorem for that. Also quite useful if you want to find the distance between 2 points. So if you've got 2 points on a grid, you can find the distance between them by using Pythagoras' theorem as well. So Pythagoras' theorem is really, really useful. I like to call it Pythagorus, as I said. And yeah, I hope you find that video useful. If you do want to have some extra practice on Pythagoras' theorem, if you go to the link in the description below, that'll bring you straight to the practice questions on Pythagoras' theorem. So I hope you found this video useful. Tomorrow, remember, 3 o'clock, that'll be 97 days to go. And thanks very much. Cheers. Bye.